let's do the last part of problem 46. Again, this is our problem from the Siegel book, and this one is 46, and the letter is the letter D, and they are in page 93. Again, the problem asks to the volume of a solution 0.1 molar of potassium hydroxide that's required to completely titrate, in this case, 400 milliliter of a solution 0.15 molar isoelectric glutamic acid for this one. Glutamic acid. So now we have glutamic acid in the isoelectric form, so we have to always know the form of the amino acid that we're dealing with. So let's write the isoelectric form of glutamic acid, which would be NH3Na plus CHCOO minus so in other words, is only enough to remove the first proton becomes the isoelectric glutamic acid, right? Because it's the isoelectric, because there is a positive charge and a negative charge, so the overall charge of the molecule is 0. So that's a Witern ion. So if you are going to titrate this solution, you are going to need 1 mole of KOH to remove the 1 mole of the side chain carboxylic group, the proton from the carboxylic group there, and we are going to need another mole here to titrate the side chain of the amino group. So therefore, in the case of this, we have a relationship that's 1 mole of isoelectric glutamic acid is going to require 2 moles of KOH. And then we do exactly the same what we did before. We calculate now the number of moles that we have of isoelectric glutamic acid, number of mole of isoelectric glutamic acid. The molarity was 0.15 molar, and the volume was 400 milliliters, so the volume is 0.4 liters. So we calculated that, and the number of moles then is going to be equal 0.06 mole. Right? So in that case, we know that we need for KOH, we're going to need twice as much of that, so the 2 times 0.06, which is going to give us 0.12 mole of KOH. We know the concentration of KOA, we know the number of moles, so we can calculate the volume based again on this relationship known to us. So volume in liter is going to be equal to the number of moles divided by molarity, number of moles being 0.12, and the molarity being 0.1. So we have 1.2 liters or 1,200 milliliters of potassium hydroxide 0.1 molar is going to be required to completely titrate 400 milliliters of 0.15 molar solution of the isoelectric glutamic acid.